I am Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about computer network subject, in which the topic is a data link control services. The outcome of the data link control services are understanding, applying the fundamental error detection correction while transmitting the data between two devices. That means by using the error detection correction methods, we can detect and correcting the errors, whatever the data, whatever the information, or transferring between the two different other devices or the same network or different network. Such as these methods are CRC, parity check and checksum. By using these other methods, errors can be detected and errors can be corrected. Two, these methods which maintaining the data integrity in a network communication. Next, the outcome of the data link control services is, which is analyzing and implementing the data controlling technique. While transferring from two devices, the data controlling different types of the controlling techniques can be implemented. By controlling this data, the required amount of data can be sent to the estimated destination device. In a practical scenario, which is solving to the real world networking problems. With help of these data link control services now, real world networking problems can be solved. So these are the outcome of the data link control services. Introduction to data link layer. Data link layer. So the definition of the data link layer is, the data link layer is the second layer in the OSI reference model. OSI reference model, which is having 7 layers. From that, these data link layer now, it is a second layer. These data link layer, which is having the responsibility for device to device the communication, or from one device to another device, data can be transferred. The device to device the communication now, simply we are calling it as a node to node communication. Node is nothing but it will be considered as a one device. That means node to node communication, effective communication can be established with the data link layer. Here in a data link layer, the data, whatever the data received, that can be transmitted in the form of the data frames. Data frames in the form of data frames. Now the data can be transmitted between the node to node. Data frames can be utilized. One data frame which is having the collection of bits. Generally, these are the collection of the bits over the physical transmission media can be transmitted. Here, the purpose of this the data link layer in a network communication, which is this the data link layer now, which is which ensures the reliable communication, which establishes the reliable communication between the two devices or between two nodes on the same local area network segment. Same network segment, it will be establish the reliable communication. Here is this data link layer. Now what it is doing means now, so which is receiving the packets, which is receiving the packets from the network layer. So data link layer, which is having the below the network layer and above the physical layer. Whatever the data packets are received from the network layer, so these the packets can be divided into the number of data frames. Number of data frames, that is a data frame 1, data frame 2, that is up to dash dash n number of the data frames. N number of data frames now it will be divided into the n number of data frames. The packets. So by dividing the data frames now, these are the data frames can be transferred to the physical layer. So in a physical layer, whatever the data frames are transferred, which is convert. These are the data frames, the transferred data frames can be converted in form of the bits, in the form of the binary bits now, 1 0 1 0 1 1 1 0 0 0. So in these are the data frames can be converted in the form of the binary bits or other bytes. These bits and other bytes here, these the physical layer, via these are the some transmission or the media. Now this can be the transfer to from one device to the another device. So this is about the introduction about the data link layer. General data link control. General services can be provided by the data link control is framing service can be done. This is the first service. Now whatever the data is receiving, that data can be converted in the form of the frames. By converting the data in the form of the frames now, so it will be transferred. And error detection and correction can be done. Here error detection, that means while transmitting the data from one device to the another device, if is there any errors in a data, so that will be detected. That means 1 bit error or 2 bit error or multi-bit error or burst error. Different types of the errors can be detected while transmitting the data between the two devices. Between the two devices here, the errors can be detected. It may be here the data can be transferred in the form of the frames. In the form of the frames, the data can be transmitted. So these are all the data frames. Data frame 2, data frame 1 up to dash dash data frame n number of data frames. In the form of the data frames, data can be transmitted. While transferring the data, here is detecting the errors. It may be the 1 bit error, or it may be the 2 bit error, or it may be the multi-bit error. More than 2 bit error, now we can say it as a multi-bit error. That multi-bit errors can be detected and transfer the multi-bit errors to the destination. That will be detected at the destination side. Now the receiver the mission will be detected, and correction can be done by using some error correction techniques. With help of this error the detection the correction techniques, now the data will be transferred effectively without errors. Without redundant data or error data can be transferred to the destination. From source to the destination, now the data can be transferred, effectively transferred. Flow control. Flow control means here, if multiple devices are requesting or sharing the same resources, so at this time we can generally this the flow control mechanism. With help of this flow control mechanism, the flowing of data, same data which whatever it is which is shared by the multiple missions, it will be controlled. Access control also by using some protocol, MAC protocol. By using this the MAC other protocol, controlling the access, which is identifying the particular other device, and whatever the device is identified, for that other device the data can be sent, the information can be sent. Link management. Here the communication, that means generally in a link management what we'll do means here linking the multiple devices. Now we can link the multiple devices by using the routers and switches. Via routers and switches, multiple devices can be linked. By linking multiple devices, now the information can be transferred from one device to the another device by managing the links between the devices. Multi devices. Logical link control, LLC. Here it is a logical link the control now, which is the controlling the whatever the links are established between the devices with help of these the routers. Now the links can be controlled by controlling these the links here and identify the particular device. Now it will be transferred to that other particular other device. Physical addressing is nothing but each and every system which is having its own physical addressing, unique physical addressing. So that physical addressing now simply we can call it as a MAC address. Each and every device which is having its MAC address. Now with help of this the MAC address, so the communicating the devices, whatever the devices now, the destination devices can be identified. The communicating devices can be identified, and by identifying the communication device, the data can be transferred from the source to the destination. Data will be transferred. Here first framing. Framing, it is a data link control service, one of the data link control service. So in this data link, in this the framing, how we are going to the controlling with the framing means here large amount of data, the bulk amount of data, that means the packet, whatever the upper layer above the data link layer, whatever the upper layer which is transferring the packets, whatever the packets are transferring from upper layer to the lower layer, that is a data link layer. Now these, while coming to the data link layer, it will be dividing the data into the number of other frames. Whatever the data we are transferring, so that will be divided into the number of frames. So here these other frames are very easily managed and synchronizing. That means all the frames, all the data at a time can be transferred to the destination mission. That means a sending mission to the destination mission. Now the data can be transferred and managed. That means at a time can be bulk amount of data at a time can be transferred. Why? Because here whatever the data we are considering, that will be divided into the number of other frames. Now if you see here, header, payload, the field, and the trailer. So these are the packet data frame. Now it is a data frame. These are the data frame which is having the header field and a payload field and a trailer the field. Once if it is received, if you use the payload data is transferred to the destination mission. The destination mission now which is having again, which is receives the data in the form of header, payload field, and trailer the data here. So in this the form now, the framing in the form of the frames, the data can be transferred from sending mission to the receiving mission. That means one node to the another node, the data, bulk amount of data can be transferred in the form of the frames. So this is about the framing. The components, generally in a framing, here in a framing the header, data framing header, generally we are using the three the components here. Here is no three components we are using. One is a header component and a payload the field and a trailer field. Three components we are using. That three components now, if you see header the component, what it is doing means now this header which is containing the controlling information. That means here controlling information means source and destination MAC address or frame type. Which type of frame we are transmitting, and which is having the source MAC address and the destination MAC address. By using this the MAC address only, now we can identify the destination. Whom do you want to transfer the data, for which destination now we want to transfer the data with help of this the MAC address only. That is these are the MAC address. Now we can call it as a physical address also. Each and every system, each and every device has its own MAC address, unique MAC address. With help of this MAC address only, the destination device can be identified and transferring the data. And a payload means here the payload, the meaning of the payload means now which is having actual data, whatever the data we are going to transferring, whatever the data we are transmitting, that the transmitting data now we can keep in a payload. So in the form of in a payload field here, we can store the actual transmitting data can be stored. Trailer field. So these are the trailer field means here what it is including means now, which is having the error detection codes. Error can be detected. That means here CRC. With the help of these the CRC, whatever the data, whatever the information you are transferring. So in a transmitting information or transmitting the data, errors can be detected. Errors can be detected. Now, once the errors is detected, with help of this correction method, error correction method now, that will be corrected without retransmitting the data from the sender. So it will be the errors will be corrected and accept the whatever the data is transmitted from the sender. CRC, number of error detection codes is there. CRC checksum. Here, number of with this one here we can detect and correcting the data. These three are the components of a frame structure. Whatever the frame structure now we are taking. So these three components will be, we are considering these three components. By considering these three components, frame structures can be designed. For with help of these frame structures now, the bulk amount of data can be divided into the number of frames and transmitted the bulk and huge amount of the data in a communication media. Next service, data link control. Next service, second service is a error detection and correction service. Here is what it is doing, this data link control service now, which is detecting the errors and correcting the errors. That means which ensures the data integrity during the transmissions. This error correction and error detection method now, which is ensuring that. So during the data transmission, so it can be give the guarantee of without other errors now, the data can be transmitted between the two devices. So with help of this error detection and correction, other techniques are algorithm. The methods generally in error detection correction now, the techniques, what are the techniques we are using, what are the methods we are using means now, the methods are first checksum method. So these are the checksum methods. By using this checksum method now, whatever the data you are transferring between the two devices, two computer machines now, we can identify the errors now, can detect the errors and correct the errors. The checksum means here, so it is a simple error detection mechanism. So it is a simple error detection mechanism. Cyclic redundancy check, CRC. CRC also it is a method for detecting the errors. By using the CRC code, cyclic redundancy code now, we can detect the errors, whatever the data you are transferring. And automatic repeat request, ARQ. ARQ also it is one of the best error detecting and correcting the mechanism here. So for error recovery can be done here. Retransmitting frames if errors are detected. So this is about the methods now. Error detection correction methods can be utilized while transferring the data between the two devices. Here, next the mechanism is a flow control mechanism. Flow control mechanism, what it is doing means here, now, in this the flow control the mechanism, we are managing the data rate. Data rate can be managed. Data transferring rate can be managed with help of this flow control mechanism. That means whatever the data transferring between the two devices over the network, so to preventing the data loss and improving the performance by flow control the mechanism now, preventing the data loss. If is there any data loss now, that will be prevented and improving the overall the performance of the network. And the data transmission rate and overall performance of the network can be improved. Generally in a computer or the system or in a computer or the networking, generally the techniques of flow controls in a DLL, the techniques of flow control in a DL. Generally, we are using in a computer system which has stop and wait flow control. Another technique is a sliding window flow control. These two techniques can be utilized. Here, sliding window protocol. Sliding window protocol now, the meaning is which is allowing the multiple frames. Whatever the packets we are transferring from one device to the another device, that will be divided into the number of multiple other data frames. Now, sliding window protocol which allow the multiple data frames to be transmitted before requiring the acknowledgement. And if you see stop and wait protocol, what it is doing now, sender transmitting one frame, after transmitting that other frame here, now which will be wait for the acknowledgement before sending the next frame. So this is a stop and wait other protocols. Now by using these two protocols, so data or the flow, that means the flow, data flow can be controlled. Whatever the data we are transmitting between the two devices here, the data can be controlled. Here is a stop and wait other protocol. What it is doing now, which is first sending the transmitting. That's from the sender side now, which is transmitting the one packet. After transmitting that other one packet here now, which will wait for acknowledgement. After getting the acknowledgement only, again the sender sending the data or information. Up to getting the acknowledgement now, which is stop the services, and with these the protocol or wait for acknowledgement. So this is about the stop and wait the protocols. Here access control. Access the control means now what we'll do in access control here, which regulating how multiple devices are share the same communication media. Whatever the devices we are using, multiple hosts or multiple devices now, which you can sharing the whenever which is sharing the same resource communication media. Now these the access control can be done. Here for example, common bus now, different types of these the devices, different types of the devices, device 1, device other 2, device 3, device 4, number of 4 devices, all computers now which is having the access to the common bus at the same time now, which is going to receiving, so which is receiving the common resources now. So with help of this the access the control the mechanism, this sharing this sharing at a time sharing can be at a time sharing can be controlled. After receiving one device, so giving the chance to another device for sharing the resources. That is so all other computers which is having the access. So in this access control now, when we are using here, whenever all computers which is having the same access common at common bus, so at the same time now we can utilize the access of the control. By utilizing this the access control now, we can controlling the accessing the resources. Here the protocols generally for this the access control now, generally we are using the protocols are CSMA CD protocol or token ring protocol. By using this token ring protocol, CSMA CD, CSMA, that means here carrier sends multiple access with the collision detection. By using this the protocol now, multiple resources the accessibility at the same time can be controlled. Actually here which is used in a wide Ethernet networking. That means this Ethernet networking, what it is doing now, so which is a wide network. Ethernet is a wide network. So these wide networks now the devices are connected in a Ethernet. The devices are connected in a same local area network, and LAN local area network, same local area network, or metropolitan area network, or wide area network, that is a WAN, LAN, MAN, WAN. So it will be the connected. The devices, the systems can be connected over the LAN or man in a man or WAN. The devices can be, if the devices can be connected and establishing the communication in a LAN, man, WAN. Here now we are saying it as a Ethernet networking. So here in these are the protocol here, CSMA, CD, now which is used in a wide Ethernet networking. So these Ethernet networking can be used in a same LAN, same man or same WAN. Token ring the protocol. Token is nothing but here the meaning of the token means collection of the packets. Here while transferring the packet collection of the packets, now that means in the form of the token, data can be, while transferring the data in the form of the tokens from the sender to the receiver. So in this other situation now we can use the token ring protocol. By using this the token ring protocol here, the collection of the packets can be transferred, which is uses the token that grants the permission to transmit. By granting this the permission here, the bulk amount of data, the large amount of data can be transferred in the form of the tokens. Here is for that now we are using the token ring the protocol. Link management. Link management that means here. So link management, the functions in a link management, what it is doing now, which is linking the multiple devices. This link management, which is working by linking the multiple devices over the routers or switches, multiple switches or multiple routers. With help of these multiple routers and multiple the switches now, the connection can be established between the different devices. Here is PCA, PCB, PCC and PCD, PCE, PCF. From for all PCs now, the link can be established. The connection can be established. For that now, link can be established from one device to the another device with the help of the routers. By using the routers now, from PCA to PCB, the link can be established. The data can be transferred from PCA to the PCB. The data will be transferred. The connection at network through the router can be done. Switches through the switches can be done. That's why here the functions in a link management now, which is establishing and maintaining the other connections between the devices. Different devices now we can maintain the connections. And also now which is what we'll do now, which is handling the initialization, maintenance and the termination of the data link can be handled. Here if you want to terminate the data link, now you can terminate the data link, or if you want to maintain the data link long time, now you can maintain the data link here. So with the in a link management. Link management here where nodes are connected through the switches and routers. Node means the PCs. PCA will be considered as a one node. So PCB is another node. PCD is another node. These nodes, whatever the nodes now we are considering, whatever the PCs we are considering, so these are the PCs can be connected through the routers, or the switches. So it will be connected. And which is managing the path. This can be manage the path for data communication within the network only. This is the with help of the link management. And if you see the logical, so the logical link control. Logical link control now, the role of the logical link control, what it is doing, that means here, which is managing the communication between the two devices over a single link. So this link control now, which is having only the single link now, with help of this single link now, which is managing the communication between the two devices. That means here logical link. Now the data link layer in a OSI reference model, whatever the reference model you are using for data transparency, in this data transparency, the number of physical layer, data link layer, network layer, transparent number of layers, among that now the data link layer. So which is a data link layer now, which is having the two other sub layers. What are the two sub layers? Means one is a logical link, the control is a one sub layer, another one is a media access control is another sublayer. These two layers now which is having. By using these the two other layers now, establishing the other links, and by establishing the link between the two devices and providing the other communication. Here the functions are what it is doing now, which is providing the multiplexing of multiple protocols over the same network, and which is defining the service access point, that is the SAP, service access point, for protocol access. Whatever the protocols now we are accessing, for that now which define this some service points. Generally in this logical link the control layer, generally we are using logical link control layer is a sublayer of the data link. So two sublayers, the data link having the two sublayers, medium access control and logical link layer. So this logical link layer, what it is doing now, which is handling the errors. Whatever the errors are attached, by the hackers to the transmitted data. For that the transmitted data now, what will do means here. So this link layer the control. Link layer controls now errors attached by the attackers that can be identified and detect those errors. So that means which handles the error checkings. Flow control and frame the synchronization can be done. Data flowing can be controlled. And also here another one, the MAC, that means medium access the control layer. This medium access also is one of the sub layer of the data link layer. Now with help of this medium access control layer, now we can identify the particular destination. Here is next the physical addressing. Physical addressing. What is the physical addressing means now? Each and every computer machine or each and every other device which is having the physical address. So we can define the physical address, that is a physical address now, also we can call it as a MAC address. Each and every the device had the manufacturers now, the manufacturers, the PC manufacturers, laptop manufacturers now. So they will give the one unique MAC address for the other devices. That MAC addresses now we can call it as a physical address. Here by using this the physical address, that means using of this MAC address, we can identifying the device on a network. Over this the network here, if you want to identify the device, that the device can be identified. So the purpose is now which ensures the frames all deliver to the correct destination. By identifying the device here now, the perfect, the exact destination, the correct destination, the data can be transferred. Here is the physical addressing now, which is refers to the use of the MAC address, that is a medium access the control addresses in a network to uniquely identify the devices at a data link layer. Here this is about the physical addressing, and the key points generally we are using in a physical addressing are the MAC address, format, scope. Here is the MAC address. Each network device such as the computer, router or printer has a unique MAC address. Unique MAC address here. The manufacturers now they will give the unique MAC address for the computers or routers or printers, whatever it may be, assigned to its network interface. This MAC address can be assigned, mapped to the network interface cards by the manufacturers. Here is the format of the MAC address. Generally MAC address now can utilize 48-bit address. 48-bit address MAC address is generally here we are using the 48-bit address, which is represents in a hexadecimal format. For example, the hexadecimal other format here 001A colon 2B colon 3C colon 4D colon 5E. So this is the MAC address of the format, general format of the MAC address. The scope of this one here, the physical address are used within a local network or the segment for direct other communication between the devices, between two other devices over the LAN, MAN, WAN. Routers which is use the IP addresses for other communication across the network. Here With help of these the IP addresses now the routers via these routers now the communication can be transferred. That means data can be transferred via the routers with help of this the IP address. Now each and every device having its own IP address. Now with the help of this the IP address here, which identify the device, and transfers the data to the particular other destination. So while MAC addresses are used with the specific other network, here generally with help of this the MAC address now, device A having its own MAC address. Similarly, the device B also which is having its own MAC address now. With help of this one MAC address now, we can identify the device A and device B. So the MAC address that will be, these devices are connected to the switches. Are, so it may be connected to the other routers by connecting the routers and switches here. So this data link the control is one of the service. Physical addressing also. So with help of this MAC address now, can identify the destination device. By identifying the destination device, the data transmissions can be done. The data can be sent to the destination mission. That means it is a local networking communication by using the MAC address. So for this data link control other services, the textbooks are the Foregen, Foregen Data Communication and Networking, Tata McGraw-Hill's 5th edition, 2012, and S. Tenenbaum, Andrews S. Tenenbaum, David J. Wetherall, Computer Networks. So 5th edition, 2010, that is a Printers Hall. These two textbooks are good for the data link control services. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.